This video is going to be focusing on graphing polynomials. That is, if I'm given a polynomial equation written in factored form, can I draw a quick sketch of the basic shape and get an idea what this graph should look like? So to do this, we are going to focus on where are the zeros, which is why we're using factored form. Remember the multiplicities when we're looking at this. We're going to look at where is the y-intercept to give us an idea of scale on it a little bit. And then we're going to look at the end behavior. And again, we can get the end behavior by looking at the leading coefficient. That gives us a degree, and it'll also give us that positive or negative. So I'm going to go through a few examples, just finding these parts and then graphing. For our first function, we have negative 2 times x plus 3 times x minus 1 times 2x minus 5. First thing, we're going to look at the zeros. Remember, the zeros are the values of x that will make a factor equal 0. So I have 3 factors here. I'm going to get 3 zeros. At this one, what value of x makes x plus 3 is 0? That's going to be x equals a negative 3. We'll look at x minus 1. What value of x will make this 0? That give us x equals 1. Those I can just look at and take the opposite. Now this one I have a little bit more going on, so I want to know what's going to make 2x minus 5 equals 0. So I'll add 5. Just solve our basic two-step equations. Just remember this, divide by 2. And we're going to get x equals 5 over 2, 5 halves, or 2.5. Those are going to give us our zeros. Now, if we notice, we just have no exponents on there, no repeated zeros, so all my multiplicities are 1, so I don't have to worry about multiplicity with this. For my y-intercepts, that's where I'm going to look at, I'm going to multiply all of my constant terms together. So I'm going to say y equals a negative 2 times 3 times a negative 1 times a negative 5. So that gives us 5 times 3 is 15 times a negative 2 is a negative 30. So my y-intercept is going to be at the point 0, negative 30. For my leading term, I'm going to, again, on each factor, I'm going to multiply the leading term of the factor. So I'm going to take the 2x here, the x here, the x here. Now this doesn't have an x on it, so this negative 2, not only is it the constant, but it's also the leading term of this part here. So I'm going to take negative 2 times x times 2x. And that gives me a negative 4x to the third. So this is going to be odd and negative. So odd and negative is going to work like a line with a negative slope. Odd is going to be like a line, negative slope, so it's going to go up on the left and down on the right. As x gets bigger, y is going to get smaller. Now with this information, I can draw the graph. Well, the first thing I need, of course, is, let's put some numbers on this graph. My x values, I'm going from about negative 3 to 2.5, so I'm going to spread this out a little bit. Negative 1, negative 2, negative 3, 1, 2, 3. On the y-axis, I know I have to go down to at least negative 30. So I'm just going to go negative 10, negative 20, negative 30. I don't really know how far it's going to go down, how far it's going to go up, but that gives me at least a place to start. If I want more, I can put more work into this to get a better graph, but basically, we're just trying to get a general shape, general form of this. So now where I have numbers on here, I can find my zeros. So x equals -3, it's going to cross here. X equals 1, it's going to cross here. X equals 2.5, it's going to cross here. They are all multiplicity of 1. There's no repeats, so it's just going to cross through the axis at all those points. My y-intercept is at 0, -30, so it's going to cross the y-axis right there. My end behavior says it has to be going up in this direction and down in this direction. With this, I can kind of get an idea of how to draw on this graph. So I'll start up high. I got to come through 3. I'm going towards the 1 here, so I'm going to say it's going to come down here probably and back up again to go up to 1. It has to come through 2.5, so it's going to come up and come back down again, and now it's going to go through the end behavior going down. Again, this isn't a perfect graph, but it gives us the idea of the basic shape. Oops, I don't want that. It gives us this end behavior. It gives us our zeros, our y-intercept, the important features that we're getting off of that. So, again, you want more detail, you go to a program to graph it, your calculator, decimals. Let's just do a couple more of these. And again, we're just going to do the same thing. Zeros, y-intercept, leading term. On this one for zeros, I got a factor here. Let's get off the arrow. X squared. X squared is going to be 0 when x equals 0. But this one's squared, so this has our multiplicity of 2. There are 2 zeros at x squared. So we'll have to take account of that. X minus 3 is going to give us a 0 at x equals 3. X plus 1 is going to give us a 0 at x equals a -1. Y-intercepts, we again look at our constants. Here, x squared, the constant is going to be, that's an x squared minus 0. So the constant is 0. So I take 0 times -3 times a 1. So the y-intercept is going to be 0, 0. If 0 is an x-intercept, then 0 is a y-intercept. That's kind of nice. Last one, leading term. I take, again, highest term, x squared. I got an x, and I got an x. So this is x to the 4th, not 4x, x to the 4th. So that's going to be positive and even. So my end behavior is going to be like a parabola that opens up. So both ends are going to shoot upwards. So I'm just going to put that on my graph right away. Both ends go up. I got to get to my numbers, so let's put some numbers on here. I'm going from a -1 to 3. So let's spread this out a little bit more. Here's -1, 1, 2, 3. 1, 2, 3. My y-intercept is 0, 0, so I'm really not sure how high or low it's going to go. I can find that out by plugging in more values for x, but for this purpose, we're not going to really bother with that. So my zeros, I have a 0 right here, but I'm going to make sure a point that has a multiplicity of 2. I have a 0 at -1 and a 0 at 3. And my y-intercept is also here. So we're going to start up. It's going up on this end, so it's going to come down to the 1. That has a multiplicity of 1, so it's just going to punch on through. It comes and it curves around to hit to this 0, but since that's a multiplicity of 2, it's going to bounce. So it's going to hit that and come back down until it can come back up to go to 3, and then we have our end behavior going in that direction. So again, multiplicity of 2, if it's an even multiplicity, that's where it's going to bounce. If it's an odd, it's going to punch on through. Let's just look at one more example here to kind of see an odd multiplicity. Notice here I have an x to the third. Hey, yeah, let's play with that. Okay, my zeros. Again, here I have this factor, and I'm on an arrow again. My factor is negative 1/2 x, so my 0 is x equals 0. Here I get a 0 of x equals 1 for my x minus 3. But since it's a 3 here, that's a multiplicity of 3. X plus 2 is going to give me a 0 at x equals a negative 2. Going a little faster than I'm. And again, we have this one squared, so that has a multiplicity of 2. And finally, the factor of x minus 4 gives us a 0 at x equals 4. Again, since I have this first factor is just negative 1/2 x, negative 1/2 x plus 0, my y-intercept is again going to be 0, 0. That takes some of the fun out of things, doesn't it? Oh, I don't know. 0, 0. I get to my leading term. I'm going to again take the negative 1/2 x times an x, but that has a multiplicity of 3, so that's an x cubed. I have here an x, but again, an exponent squared on here, so that's really an x squared. And then a single x here. So we have 1, 2, 3, 4, 5, 6, 7. So this is going to be negative 1/2 x to the 7th. So this is again going to be a negative odd. So it's going to be coming and behavior like a line with a negative slope, going up on this end, down on the other end. So we'll come up here, down here. We get our numbers on our graph. We need to get out to 4, back to negative 2. So we'll go like that. We'll put in our zeros. We have 1 at 0, 0. At 1, I have a 0, but that has my multiplicity of 3. At negative 2, I have a 0. That has my multiplicity of 2. And then at 4, I have a 0. I look at my y-intercept is again at 0, 0. So you notice I didn't put any numbers on my y-scale because I don't really know any numbers. And that with this information, I'm just kind of estimating what it looks like. But I can get, is it a relative minimum? Is it a relative maximum? I just don't know exactly where it is unless I want to do more work. So we're starting, and behavior says I go up when x goes negative. So I'm coming down. But this has a multiplicity of 2, so that's going to bounce. So it's going to hit that and come back up again. Let's make that look a little nicer. And I'm being picky here. So we bounce here, we come back up to go down to 0, 0. Now, that's a multiplicity of 1, so I go straight through it. Now here, multiplicity of 3, so I have to curve up to hit there. Again, with 3, I'm going to level off a little bit. It's not going to be a straight bounce. It's going to level and say, nope, I'm going to go through. But there's that little hesitation there. And then it'll come up and then back down at 4. That's a multiplicity of 1, so it's going to punch on through. And it's going to be down, which again hits our end behavior. So we got basically this idea. It really comes down to find the zeros by looking at the factors. What makes the factors, what x value makes each factor equal to 0? Look at the multiplicities. That's going to have an effect. Find the y-intercept. That's a nice double check sometimes to make sure you're going the right direction. Find the leading terms. You multiply the leading terms together. A reminder to find your y-intercept if you don't have a 0, and it's not 0, you just take the leading or the constant terms from each factor and multiply them together. So then with the leading term you can get, is it even, odd, is it positive or negative, and give you your end behavior. And then we go graph this. So go ahead and try some of these on your own.